Welcome to Story Spectrum. Ever wondered how the sleek device in your pocket, the powerhouse on your desk, or the server humming miles away came to be? From room-sized behemoths to pocket-sized geniuses, this is the incredible breakneck speed history of the computer. Let's rewind the clock. Our story doesn't start with silicon, but with gears and looms. In the 1830s, Charles Babbage, a British mathematician, dreamt of a machine he called the analytical engine. It had a mill for calculating and a store for memory. Sound familiar? It was the conceptual blueprint for a general-purpose computer. Alongside him, Ada Lovelace, a brilliant visionary, wrote what's considered the first algorithm for this machine. She wasn't just a programmer. She saw its potential beyond mere number crunching, imagining it could one day compose music or create art. Sadly, the technology of their time couldn't build their dream, but the seed was planted. Fast forward to the 1940s, a world at war. The need for rapid calculation was critical. Enter the giants. In the US, ENIAC, the Electronic Numerical Integrator and Computer, roared to life. This monster weighed 30 tons, filled an entire room, and used over 17,000 vacuum tubes. It was a power-hungry beast, but it could perform calculations 1,000 times faster than any human. It was programmed by physically rewiring it, a painstaking task performed by a team of brilliant female mathematicians. Around the same time in Britain, another secret hero emerged, Colossus. Developed at Bletchley Park, it was designed to crack encrypted German messages, playing a pivotal role in the Allied victory. These first-generation computers were massive, expensive, and purely for government and military use, but they proved that electronic computing was possible. The 1950s brought a revolution in miniature: the transistor. Invented at Bell Labs, this tiny semiconductor device replaced the bulky, unreliable vacuum tube. It was smaller, faster, cheaper, and used far less power. This kicked off the second generation of computers. Machines like the IBM 7090 were still large by today's standards, but they were a huge leap forward, opening the doors for businesses and universities to harness computing power for the first time. Programming also became easier with the development of high-level languages like Fortran and COBOL, allowing programmers to write code in something closer to human language. Then, in the late 1950s and early 60s, came the next game-changer, the integrated circuit. The idea was simple but genius. What if you could put multiple transistors and other electronic components onto a single, tiny chip of silicon? Jack Kilby at Texas Instruments and Robert Noyce at Fairchild Semiconductor independently developed this technology, paving the way for the third generation. Computers became smaller, more powerful, and even more affordable. The IBM System 360 was a landmark series, offering a range of compatible machines for different business needs. This era also saw the birth of the operating system, the soul of the machine that manages all its hardware and software. But the real magic trick was yet to come. In 1971, Intel packed the entire central processing unit, the brain of the computer, onto a single chip, the microprocessor. The Intel 4004 was born, and the fourth generation of computing had arrived. This single chip had the same computing power as the original ENIAC that once filled a room. The personal computer revolution was now inevitable. The late 1970s was the Wild West of personal computing. Garages in California became legendary workshops. In 1976, Steve Wozniak and Steve Jobs unveiled the Apple I, a bare-bones kit for hobbyists. A year later, they launched the Apple II, a fully assembled, user-friendly machine that became a massive success, bringing computers into homes and schools. At the same time, companies like Commodore and Tandy were also selling millions of their own PCs. The race was on. Seeing this new market explode, the giant IBM decided to jump in. In 1981, they released the IBM PC. But they made a crucial decision: they used an open architecture, meaning other companies could make compatible hardware and software. They chose a little-known company called Microsoft to provide the operating system, MS-DOS. This combination of IBM hardware and Microsoft software created a standard that would dominate the industry for decades. The era of the PC clone began, and computers started appearing on every office desk. As hardware got faster, software got smarter. The command line interface, where you had to type cryptic commands, started to give way to something more intuitive. Inspired by research from Xerox PARC, Apple launched the Macintosh in 1984. It introduced the world to the graphical user interface. Or GUI with its windows, icons, menus, and a revolutionary new pointing device, the mouse. You no longer had to be a programmer to use a computer. You could just point and click. It was a profound shift that made computing accessible to everyone. Microsoft soon followed with its own GUI, Windows, which eventually became the dominant operating system for PCs. While personal computers were taking over our desks, another revolution was brewing in the background: the Internet. Originally a U.S. military project called ARPANET, it was designed as a decentralized network that could withstand an attack. But academics and researchers quickly saw its potential for collaboration. By the 1980s, it was connecting universities across the globe. Then, in 1991, everything changed again. A computer scientist at CERN named Tim Berners-Lee created a system to share information easily over the network. He called it the World Wide Web. He invented HTML, the language of web pages. URLs, the addresses for those pages, and HTTP, the protocol to fetch them. He gave it to the world for free. The first web browser, Mosaic, was released in 1993, making the web graphical and easy to navigate. The dot-com boom was on. Suddenly, the world's information was just a click away. Companies like Yahoo, Amazon, and Google were born, fundamentally changing how we shop, communicate, and learn. The story doesn't stop there. As the 21st century dawned, computing started to break free from the desktop. Laptops became as powerful as their larger cousins. Then, in 2007, Apple introduced the iPhone. It wasn't the first smartphone, but it combined a powerful computer, an iPod, and an internet communicator into one sleek device with a revolutionary multi-touch interface. It created the modern mobile era. The App Store opened up a new universe of software, and competitors like Android pushed the technology even further. Today, computers are everywhere and often invisible. They're in our cars, our watches, our homes. We're living in an age of cloud computing, where vast data centers do the heavy lifting, streaming content and services to our devices on demand. We're on the cusp of the next great leaps with artificial intelligence and quantum computing, promising to solve problems we can't even imagine yet. From Babbage's mechanical dream to the supercomputer in your hand, the history of the computer is a story of human ingenuity, relentless innovation, and the desire to make the impossible possible. It's a reminder that the most powerful ideas can start with a single spark of imagination. Thank you for watching. If you enjoyed this journey through time, don't forget to like, subscribe, and hit that notification bell. We'll see you in another story.